Okay, so for the arc sine, the domain is from -1 to 1. Now remember when we were graphing sine of x, where the domain was 0 to 2 pi, we would have the inequality from 0 to 2 pi. Now we're going to have the inequality go from -1 to 1. And it's arc sine of 3x, so 3x will go in here. So my domain is going to go from -1/3 to 1/3. All right? So on the x-axis, I'm going to go from -1/3 to 1/3. Now, the range for the arc sine goes from -pi/2 to pi/2, and we're not changing the range here. So we're going to go from -pi/2 to pi/2. Oh, sorry, this is the y. Okay? It's the y. The range is the y. So the y values are going to go from -pi/2 to pi/2. Yeah.
Is that the way you want us to write it when you say state the domain and range? Or do you want it like...
Either for now and then, okay? So now, yeah.
Can the y ever be like 3y or...
No. Okay, so the graph, the function I'm given is inverse sine of 3x, right? What I'm going to do, I'm going to show you the more practical way of graphing. We're going to take the sine of both sides. And when I do that, I get sine of y equal to 3x. And now I can solve this for x, and it'll be 1/3 sine of y is equal to x. Okay? Now, I'm going to pick points. So my x is now 1/3 sine of y, and this is my y.
Sorry, what is the opposite sine of y?
So I took the sine of both sides, sine of y, sine of inverse sine of blah, blah, blah. Now, we're normally used to, we're programmed to have the xy table, and we choose values for x, plug them in, and get y. Now we're going to go in the opposite direction because we're doing inverses. We're going to choose values for y, plug them in, and get the x. Okay? We're going to choose values for y. I know my y values go from -pi/2 to pi/2. So why don't I choose those values? So -pi/2, -pi/4, 0, pi/4, pi/2. Okay? Now, let's plug each of those values into our x. So x is 1/3 sine of -pi/2. So what about sine of -pi/2? -1, so this is -1/3. Now, x is 1/3 sine of -pi/4. At -pi/4, it's -√2/2. So this is -√2/6. X is 1/3 sine of 0. How much? 0. X is 1/3 sine of pi/4. Right. 1/3 sine of pi/2. 1/3. Okay. Now, the values I will be graphing, or plotting rather, are the x values that I just found here, along with the y values there. Okay? So, when y is -pi/2, when y is -pi/2, x is -1/3. So when y is -pi/2, x is -1/3. That is here. When y is -pi/4, x is -√2/6. Now, can somebody give me the value of it on their calculator? -√2/6. How much?
If we can do it quicker, do we have to do the table?
Point what?
0.24.
0.24, right? So that's going to be somewhere over here. What was your question?
If we can do it like mentally,
Mhm.
points,
Mhm.
then do we have to do a table?
No, not absolutely. Absolutely, you could do it without. So at 0, we're at 0. When y is pi over 4, same deal. Root 2 over 6. And at pi over 2, it's 1/3.
I think that one of the points wrong. You did pi with 2 twice.
We estimate where like root 2 over 6.
One is negative pi over 2, one is pi over 2.
No, it did like, where it should have been pi over 4, you did pi over 2.
Oh, I wrote pi over 2, but it's pi over 4.
But aren't we supposed to do the inverse? So technically, aren't we supposed to switch the x and y values?
We did, right? So we did switch the x and y. So basically we solved for the x, okay?
Oh, is it not on the point? So like, root 2 over 6 is not on the line?
Right, it's somewhere in the middle. Because it's, I'm incrementing by 1/3, so that's 1/6, and it's somewhere in the middle. All right? So this is what it will look like. It's important that you have the endpoints because you know that it's a restricted domain and it doesn't go above or beyond that. Okay? Now, students like to give this much more of a curve than it should have. Just make sure that it's that it curves once like this and then once down. So it's like a full cup on the top and then I'm sorry, it's like a right side up cup here and then an upside down cup over there. All right, so let's do a tangent. Now, when we talked about inverse tangent, right? We said the domain is all reals, negative to positive infinity. So here too, no matter whether you have arctangent of x over 2, arctangent of 5x, the domain is always negative to positive infinity. Now, the range, you notice, it went from negative pi over 2 to pi over 2, but it was open parentheses. And in these problems, we're not going to change the range. We're just going to change the domain, if at all. So it's negative pi over 2 to pi over 2. Okay? Now, we're going to solve the equation, same situation. This is inverse tangent of x over 2. And I'm going to take the tangent of both sides. So I have tangent of y is equal to x over 2. Right? So what's x equal to? 2 tangent of y. All right? Now, let's pick some points here. So again, x is 2 tangent y. And y is going to go from negative pi over 2 to pi over 2 again. So x is 2 tangent negative pi over 2. Right? What's tangent of pi over 2? Or negative pi over 2? Tangent of pi over 2 is right is at the top, right? It's 1 over 0 is undefined. So when y is negative pi over 2, the graph is undefined. There are no x values. That means there is an asymptote there. Okay, there's a horizontal asymptote there. All right, so x is negative 2 tangent of, positive 2 tangent of negative pi over 4. Tangent at negative pi over 4 is negative 1. So here this is negative 2. Now, 2 tangent 0 is just 0. 2 tangent pi over 4 is 2. 2 tangent pi over 2 is undefined. Pi over 2, sorry, is undefined. So at pi over 2, I also have another asymptote. Now, at negative pi over 4, we are at negative 2. 0, we're at 0. And positive 2 here. All right? Yeah. I mean, yeah, technically they do continue. I don't normally put arrows, okay, but that's what it would look like. So now you do have all the information you need to complete the homework for this section. So let's just remind ourselves what this problem was about. So we're sitting in a movie theater, right? And there is a screen. We had to figure out an expression for the viewing angle theta. So the viewing angle is the angle that you see the screen at. And we came up with that equation as this. Now here it says, in part B, determine the distance that corresponds to the maximum viewing angle. All right, well, the viewing angle is theta, right, in terms of D. And what we want is the maximum of that. So what we're going to do is graph this. So let's graph. All right, it's going to be inverse tangent. So that's second tangent, 36 over D. D is our x, right? It's our variable. Minus inverse tangent, 4 over x. I'll fix the plus. So that's that. Now, let's think about what any of this means. So if I have a graph, right, let's just talk about the meaning of these variables. Normally, my graph is in terms of x and y, but now I have theta and d. So is the theta the variable that corresponds to the y or the x? Is that the independent or the dependent? X or y? Theta is your dependent, so it's your y coordinate, right? So in this case, here's my theta, and this is my d, okay? So d is like our x, it's our independent variable, okay? Because the distance changes, and then based on the distance I am away from the movie screen, the viewing angle will change, okay? Now, we're graphing a trig function, so and in this case, it's the particular problem. When we're talking about like the physical angle, we don't want to be talking in degrees. We want to be talking in. We don't want to be talking in radian. We want to be in degrees. So let's go to degrees. And before I graph, I want to choose the trig zoom. So under zoom, this is the 7th option. So I just say zoom 7. All right. Now, you're not going to see anything. Okay? Obviously not. Because if you go to your window, look at your x. Okay? That's, x is our distance, right? It's going from negative 352 to 352. And that just doesn't make sense for our problem. Y is the angle, and it's going from negative 4. So these, we need to fix those. So the distance, let's go from 0 to how far do you think? 100 feet. Let's leave it. Well, this is the distance you're away from the movie screen, right? And the x scale, that's, let's do 10. That's how big each increment is, right? So like each tick is at 10 marks. Okay. Y is our angle, right? So now take a look at that drawing, right? What are your values, do you think, for your angle? if there's no angle, it's 0 degrees, and then what's the maximum the angle can go to? 90 in this case, right? You're not gonna have a 180 because that means you're here and the screen is behind you.
You could be looking 90 degrees and still have the screen.
No, but that's the maximum, right? Right. So what? Or you're so close, right? So I mean, we have to put a number here, right? We know it's not going to hit 90, but we have to put a number there. If you want to put 85, put 85. But you know, I'm just gonna go to 90 here. So let's just graph this. Okay, there we go. You see it? Okay, so now we want to find the maximum here. To do that, we do second calc. Maximum is number 4. All right, and this is the important part. You have to take the cursor to the point that you're looking for. Okay, now you're going to go to the left a little bit. Doesn't matter how much, just a little bit, enter. And then you have to go to the right, past the point and go to the right of the point that you're looking for. So here we go. It's at 11.9999 and then y is 53. So what does x represent in the context of our problem? The distance. So the distance is 12 feet. So when you're 12 feet where? In what direction? When you're sitting, if you're sitting 12 feet away from the screen, then you get a maximum viewing angle of 53 degrees. Okay, so that's when your viewing angle is the maximum. Okay, yeah. So it says determine the distance that corresponds to the maximum viewing angle. So the maximum viewing angle of 53.1 degrees is achieved when sitting 12 feet away from the screen. All right. So the point of this problem is first to figure out, you know, if to be able to calculate maximum values, and also to be able to translate the traditional x and y to the context of this problem, to be able to fix your windows so that they make sense. All this happens when you have an understanding of the problem. Okay? Okay, so the maximum, okay, so the viewing angle is D, right? It's D. So look, in trace mode, if you're at 90, if the angle is 90 degrees, all right, you're not gonna, like, you're not sitting at a prime position in the movie theater. Okay. All right. Let me stop this.